So hello guys, welcome back to my channel. And in last video, we have talked about what is the measures of central tendency. And today we'll talk about what is the measures of variability and spread. So we'll mainly talk about what is variance and standard deviation. Okay. So what I'll be doing, I'll be starting with a problem so that it will be very clear like why we study variance and why we study standard deviation and what is the significance of that, right? It's not only that like you should understand the definition and formula and that's enough. That is not enough at all. Okay? At least in data science, but that is not enough. Okay. So let me start quickly. So let's understand with one problem. So there is a basketball coach, and he has to select one player in the team. Okay. So he's a kind of statistician. So he believes in statistical data. So what he is doing, okay, instead of taking some blind decision, he is collecting some data for the like three available choices. So he has three players, and he has collected the data of the last 10 matches, okay, for each player. So like this is the data for player one, like he has scored 7, 8, 9, 10, 11, 12, and 13 in previous 10 matches, okay, respectively. And this two is like frequency, like two times he has scored 10 and two times he has scored 11, likewise, okay. And then similarly, we have data available for player two as well and player three as well, okay. So, like a general thing will be like if you want to select a player, so what we will do, we will see, okay, on an average, who is scoring better, like who the player who has a better mean score, will go with that one, right? So, what we do, we calculate the mean like central tendencies for all three players. So, like we'll calculate mean, median, mode. So, and now we got, okay, mean, median, mode of all these three players are 10. So, on an average, like all the three players score like same score, right? Yeah, historical score. So now the basketball coach is confused whom he has to select. Okay, so now the problem arises. Now there is a question whom he has to select. Okay, so that's where like measures of central tendencies are not enough. So that's where we go with measures of variability and spread. Okay, so we'll see like what is the variability in his score. Okay, so that's where we'll study variance and standard deviation. So let me start. Okay, and then we'll again come back to this question and we'll solve that one. How to what will be the better choice? So now let me explain the first the variability. Okay. So variability is nothing but like if there is a mean point, we calculate the mean score. Okay. And with respect to the mean point, what is the like variability? Like what is the stretch of different data points? Okay. So if you see the green curve here, so green curve is like stretched both sides, like right and left, both sides, a little bit more compared to red and blue one, right? And if you talk about the red one, so it has a peak, it has a spike, but if you just focus on the mean point, then with respect to mean point, its stretch in both sides is less, right? And then if you talk about the blue point, then blue point is in between the red and green curve, right? So in that sense, like red one has a low variability and the green one has a high variability and blue one has a medium, like in between these two, okay? So let me explain with some more example, then it will be more clear to you. Okay. So what we can do, so suppose you have, so for this kind of understanding, like a scatter plot helps you. Okay. So in next video, I'll be explaining more about a scatter plot. But for now, like a scatter plot, like just put your data points on the space on the X and Y axis. Okay. So, for example, we have scores of different players, and so for example, let's take player one, okay, and we have a mean point. And if, for example, if you forget about also the player, just you have some random data, and that mean point is this one, okay. This is the mean point. And if we draw a line, for example, x-axis, okay, so here there is a mean point. Hmm? So now we put other data points, like one data point could be here, one data point could be here, one data point could be here, like that. Okay. So different data points could be there. So if you plot a scatter plot, then you will see these data points like that. Okay. And now, how to understand the variability? So variability is nothing but like if you have a mean point, okay. So suppose this is your mean point. Okay. And around this mean point, what is the distance of each and individual data point? So that is the variance. So that is the variability of that particular data point with respect to that mean point. So what we do, we just project every point in this axis. Okay. Like that. So this is a straight line, guys. Okay. And like that. each and every data point. So just this is a straight line, okay? So for example, if you consider this point, so what is the distance of this point to this mean point to this? So this point is far with this distance with respect to the mean point. So this is mean point and we are denoting it with mu. Okay, this is mean point. And then if we talk about this point, right? This point is this much far from the mean point. This much far. And if we talk about this point, so this point is like the farthest point on left side. Okay, so this much far. So this point mean distance from the mean point is this much. Okay, and likewise, so this point is this much far from the mean point. Okay, so this is with respect to individual point. And now if we talk about the average distance, so because when we talk about variability, then we talk about the complete data set, like, right? So data variability. So that's where comes the variance. Okay, so then what we do, we calculate the average distance of each data point with respect to the mean point, right? The average distance of each data point from mean point. Correct. So how we calculate the distance? Basically, we subtract the so this distance, right? So we have suppose x1 data point, and the average is, for example, mu, right? Then what we get for xi minus mu. So this is the distance, right? Distance, right? And if you want to calculate the distance for each data point, then what we do, like xi minus x1 minus mu, okay, and with respect to x2 it will be x2 minus mu, and with respect to x3 it will be x3 minus mu, correct? And if we have n data point, then it will be xn minus mu, correct? And then if we talk about average, then what will happen? We need to divide by n, right? And we need to sum them. And then here we can write dash because there are n data points, right? So x1 minus mu plus x2 minus mu plus x3 minus mu up to xn minus mu divided by n. So this becomes the average distance. Okay, and this is the variance. Okay, now there is a change in the formula, right? So when we talk about variance, we of course square. And now I'm going to tell you, like, see, some of you might be knowing the formula and you might say, okay, there is a square. So that's what I'm going to tell you, okay, why there is a square. So there is a challenge, or I would say drawback in this formula. What will happen? Okay, suppose this is the mean point, right? And we consider this as a 0 point. Okay, this is the 0 point. And right side values will be plus positive and left side values will be negative, right? And for example, this data point and these data points are from equidistance from the mean point, right? So this is suppose plus 2 and this is suppose minus 2. And when we start adding, right, these data point, this will return, for example, minus 2 and this is returning plus 2. And they will cancel it each other, right? So if we simply add them, okay, add the distances, then they might cancel each other. And then it could be a case like it could come as 0, right? So to neglect that negation effect, what we do, we square the distances, okay? Then we put like a square, like that, okay? So that becomes the variance formula. This will become your variance. So variance is nothing but the on an average distance of each data point from the mean point. When we say average, then we divide by n. And now we also understood why we are squaring to negate the cancelling effect. Okay, so because distance could be both sides of the mean point, right? And in very worst scenario, rare case, the data point in the right side, their distance, whole distance, okay, for all the data point on the right side, and the distance of all the data point on the left side is equal, but they will have opposite sign, right? And they can cancel each other, and then it will come 0. So that's it. To negate that effect, we square. Okay. So this becomes your variance formula. And then if you generalize, then it will become sigma I is equal to 1 to n xi minus mu whole square and divide by n. And that becomes your variance formula. Now let's understand some pointers. Okay. So a standard deviation, I will come, maybe let me explain here as well. Okay. So this becomes your variance formula. So now what is a standard deviation, guys? So now here again, because we are squaring the data points to calculate the variance. Okay. But our original data points are not squared, right? So there will be difference in the unit. So these variance comes the squared unit and data points are not squared. Okay. So that's where to normalize this, like this variance with respect to this data points. What we do, we take square root of variance. So this is your variance, okay, and standard deviation will become the square root of variance. Okay, we simply square root so that we get the same unit as of our data point. So standard deviation, so significant statistical significance wise, standard deviation and variance both are same. It's just like standard deviation is the square root of variance, so that we get the same, like we get the normalized value, similar to our data point. Okay, so standard deviation also tells on an average how far your data points are with respect to mean point, and that is nothing but your variability of the data points. Okay, now let's understand. So I have written the pointers for you to refer. So variance and standard deviation are the most commonly used measures for variability and spread. And variability and spread are nothing but the process to know how much data is being varying from the mean point. Okay, that we have already talked about. And variance tells the average distance of all the data points from the mean point. We have seen that. And standard deviation is just the square root of the variance. And we have also seen like why we do the square root, right? To get back the same unit as our data point. As variance is calculated in square unit and hence to come up a value having unit equal to the data point, we take a square root of the variance and it is called as standard deviation. Okay, guys? And now this is the formula which we already discussed. Okay. And why here n minus 1? Because if we talk about sample, then we do n minus 1. And if it is a population data, then we do n. Okay, so don't get confused. In sample, we do n minus 1. And in one of the video, I will also explain the reasoning behind why we do n minus 1 for sampling. Okay, because sample data is small and so that like our data point will be spread like anyway spread near to mean point. Okay, so just so that our variance will be very low and population data is very big. Okay, so that's where like to get a little bit more value of variance, we just subtract n by 1 so that denominator if is reduced, so overall value will be greater, so that we get variance of sample similar or equal, somewhat equal to the population variance. Okay, but this point I will explain in more detail in some other videos. Okay, why we do n minus 1, but in general for sample calculation we do n minus 1 here, and for population we take n here. Okay, so don't get confused, guys. So this is variance formula. We have also seen like how we got this, and simply take a square root of variance, you get the standard deviation. Okay, now let's go back to our problem, like that basketball coach again. Okay, and then we will clearly understand, okay, what is the significance of this variance and standard deviation. Okay, so this is the player 1 and this is the player 2 and 3 data. Okay, so let's calculate the variance for this player 1. So how to calculate variance, guys? So for variance, we have formula like x minus mu whole square divided by n, or n minus 1, right, guys? So for that, we need to calculate the mean, and mean we already know like how to calculate. So this is how we can calculate the mean. Okay, so just sum up all the numbers and divide by the sum of the frequencies. Right? So this comes 10. So this we have already described in previous video, like how to calculate the mean. You can refer that if you have some doubt, but this I have already written this. Okay, so this is the mean value and then variance. This is the formula for variance, xi minus mu whole square divided by n minus 1, because we are taking the sample. Okay. So here in mean, so mean is like irrespective of sample or population. So here we always take n. Okay, so don't get confused. So now for variance, like simply like this is 10 is your mean value. So x minus mu. So like that. So how many x are left? 7, 8, 9, 10, 11, 12, 13, right? So 7 minus 10 whole square plus 8 minus 10 whole square plus 9 minus 10 whole square. And 9 minus 10 will do 2 times, because 9 is coming 2 times, right? So 9 minus 10 whole square plus 9 minus 10 whole square. And likewise, we'll do all of that. Okay. And then divide by n minus 1, that is 10 minus 1. Okay, so if you solve this equation, then you will get variance value, and then if you square root that one, then you will get the standard deviation. Okay, so I have written all the number. It's very easy to solve. Okay, just pick one calculator or take your mobile and then solve this. The standard deviation will come 1.82. And guys, take care. So this is for player one. Okay, so for player one. And similarly, you can calculate the standard deviation and variance values for player two and player three. Okay, so I have already calculated. So these are the values for standard deviation of player two, that is 1.56, and the standard deviation with respect to player three, that is 7.76. Okay. So now guys, see here. As I already said, variance and standard deviations are nothing but the measures of variability, right? How much your data points are varying with respect to the mean point. Okay, and in general, variability should be focused towards the mean point, right? And if your player score is varying too much with respect to the mean point, right? Then we can say, okay, he is not a reliable player. One fine day he can score maybe very high score, and one fine day he can score very low score, and then very low and very high. If you calculate, the average will be focused in the center, right? Average will be centered even in that case also. But variability is very high. If variability is very high, then you will say, okay, he's not a reliable player, right? And that's where in sports we talk about X factor. Of course, we include some X factors also in the team, so that if that is their day, then they can hit here and there, and they will score a very huge score, right? But that is like not reliable. If we talk about reliability, so we always prefer reliability, right? So that's where the player who has least variability, so that is more reliable player, and then our coach will go with that player. And let's see here. Player 1 has a standard deviation of 1.82. So his variability from the mean point is 1.82. And player 2 has variability of 1.56. That's the least. And player 3 has variability of 7.76. So his variability is more, right? So if our decision is based on the reliability, then we will go with the player 2. Okay. And if our decision is based on the X factor, okay, then we will go with the player 3. Okay. So that's how coach will decide. I have written also for your later reference. So if you look into the standard deviation of all three players, then you will find that player 2 least deviates from the mean point. Okay. So there are high chances that he will at least score close to his mean score, because he's more reliable player. There is a guarantee at least he will score close to mean score, right? At least he will score mean score, that is 10. Okay, it's not like there are chances he will get out on. He can get out on 0 also. That's fine. But what are the chances? What are the odds? Right? There are high odds like he will score closer to the mean value. Okay? And other players whose standard deviation is high are deviating more than the mean point, hence they are less reliable. And again, guys, I also told, okay, if you are focusing, if your decision is based on the X factor, right, then you can go with the player 3 also. Okay, there are chances he can score very high, right? But simultaneously, there are chances also he can score very low also. Okay, but it depends like on what basis we want to take the decision, right? So this is all about variance and standard deviation, and I have also explained with the help of one formula like why we need variance and standard deviation. Okay, so now let's take one example also. So guys, this is the example like a company XYZ Limited wants to give all employee a raise. So same example I have taken in explaining the measures of central tendency, that is mean, median, mode. And there I have solved this example. Okay. So here I'm not going to solve you, but giving you that as exercise. Okay. You just solve and see like based on like 10% hike and by giving 2000 hike to every employee. Okay. How the standard deviation and variance value uh, changes. Okay, what will be the new variance and standard deviation value in both the cases, in case of 2000 hike and in case of 10% hike. Okay, just calculate. So that will be one exercise for you. So that's it, guys, for variance and standard deviation. And in next video, I'm going to talk about some other variability and spread, that is a range. We'll talk about interquartile range, and we'll also understand the outlier. Okay. So that's it for this video. I hope you liked, and if yes, then please don't forget to subscribe my channel and hit the like button. So that's how you'll get the notification for any upcoming videos. Okay. And please also don't forget to share with your colleagues or in your network. Thank you.